Okay, good morning class. Alright, please click the link and also enter the code, okay, for the class point. Okay, for those who just enter the class, okay, wait for a while, I give you the link. Okay, if you use your phone, you can just scan the QR code there. Eight more students. Sorry, I checked the list name first. Elections is here on. Where is Wyman? Wyman, would you join the class point? Can I see your name here? Mention. Okay. Zingzen. Okay. Jiaen. Jiaen. Okay. Zinian. Zinian. Zinian, yes. No, Che Zinian. Okay. Che Wei Lok. Che Wei Lok. Wei Lok. Where is Wei Lok? Okay, yeah, you are the same. Okay, Jian Yu. Okay, Hao Qin Hao Okay, Wai Hong. Wai Hong. Wai Hong. Qin Wai Hong. Where is Qin Wai Hong? Qin Wai Hong. Are you here? Teacher, can you send the link? Okay. Vinshan, please check the attendance who's still not here. Wei Zhen. Wei Zhen. Okay. Daniel. Daniel, okay. Yongxing, okay. Joey, yes. Hazel, okay. Kavinesh, okay. Lai Jian Hong, okay. Lavanya, okay. Lee Cheng Chi, Okay. Lee Yongjun. Okay, Lee Kelly. Okay, Kelly. Okay. Kwan Zing. Lim Kian Zing. Lim Kian Zing. Where is Lim Kian Zing? Okay. Yes, alright. I see your name. Jiang Wei. Liu Jiaru. Okay. Lo Chi Seng. Okay. Lu Ling Jing Yi. Lu Ling Jing Yi. Okay, Jing Yi. Ng Jing Yi. Okay. Teacher Alice, Elvis, Ethan, and Lee Wendy. Okay, that's for one. Ng Yong Wei. 54. Okay, already here. Alright, so let's continue to our lesson today. Okay, so last week, right? Last week we already learned about the constructive and also the destructive interference for the water wave. Okay, so I want you to do now, I want you to label. Okay, I give you 4 points, A, B, C, and D. Okay, so I want you to label which one is the constructive interference and which one is the destructive interference, right? So constructive is when crest meet with the crest or throw meet with the throw, while destructive is the crest meet with the throw. Okay, so for this, we just join. Ethan, please join the, alright, Ethan already joined. Okay. Okay, KD, Wazel, Kaiser, Lavanya, Zeniep, and Ethan. Teacher, I can reply origin again. Okay. Okay. Hazel, where is Hazel? All right. So let's check the answer here. Okay. So which point is the constructive and destructive interference, right? So you can see actually the dotted line is throw and y the line. Okay, that one is the crest. Okay, so let's see at point A. So that one is a throw meet with the throw, so then we form the constructive interference. Okay, so constructive interference. While at B is a crest meet the throw, so this one is a destructive. Okay, while C is actually crest meet with the crest, so this one is the constructive. And D is the crest meet with the throw, so this one is a destructive. Okay, A, C, B, D. What happened at the point B and D? You have to mention to me what happened to the A is a destructive, A is a constructive. One is a throw meet with the throw, this one. Right? Negative A with negative A become negative 2A. So this is the constructive. Okay, good. Okay, this one, Janu, C is the constructive, B is the destructive. Okay. B and D is the destructive, AC constructive, B and D destructive, correct? Okay, constructive A and C, B, D, good. This one is wrong. A is actually constructive, B is a destructive. Okay, and C is a constructive, D is a destructive. Um, this one is wrong. Okay. Mm, okay, constructive, destructive. Okay, so let's check. Okay, what is actually a constructive and destructive? Okay, so let's go through again. Okay, so let's say if I have the what, this is the two source, okay, for the water wave, right? And you can see they overlap with each other, right? They will overlap with each other, okay? So the one, the dotted line is actually the throw, okay? The dotted line is the throw, okay? It's mean this one. Okay, while this line, okay, is a crest. Okay, so let's say if I take at point A, okay, so here at point A, so this one is actually throw meet with the throw, so it will be like this, right? At point A here, dotted lines meet with the dotted lines, right? So meet it should be throw meet with the throw. So this one, the amplitude is negative A, and this one is a negative A. So by using the superposition, position of the principal, right? So this one should be negative to A. Okay, so this one we call it as the constructive interference. Okay, so for the next one, let's say I take the point B here. Okay, at the point B is actually the crest meet with the crest. Okay, you can see the line here, it meet. So the crest meet with the crest, so it will become, they say this is the A, the amplitude is A, and this one is the A. So A plus A will become 2A, right? So this one is also a constructive. Okay, and let's see for the C, point C here. So this one is actually the crest meet with the throw here. So this one is a positive A, and this one is a negative A. So positive A plus negative A, you will get 0. So this one is a destructive interference, right? So that is actually the constructive and also the destructive interference. Okay. Are you clear? Anyone want to ask anything about the constructive and destructive interference? Okay, let's try another one. Okay, make sure that all of you understand what is actually the constructive and the destructive interference. Okay, so I give you a clue. The dotted line is the throw, while the line like this is the crest. Okay, so you need to give me which point is the constructive and destructive. They say constructive A, B or C, D. Okay, right, so let's try again. All right, wait for a moment. Try this one. So this time, please enter the last point. It's another one. Open validation. Already. This. This is nothing. Okay, Lavanya, Shreya, Kelly, Wendy. Teacher, I like again. Did you use your, did you try to use your phone? Maybe your, or you already used your phone? If not, you just give your answer at the chat first. Using laptop. Can you try using your phone? Maybe I just give you the QR code, then you just scan the QR code. Hey, Lavanya, Shreyan. This is the QR code. Okay, Lavanya, are you here? Kelly, did you already scan? Okay. So, Lavanya, are you okay? Where is Lavanya? My connection is bad. Alright. Put the answer in the chat. Okay, Lavanya and Kelly. Okay, which point is a constructive and destructive interference? Alright, so let's see point A first. So point A is actually crest meet with the crest, right? So crest meet with the crest, it will become constructive interference. Okay, so A is a constructive. Okay, so let's see for B. Okay, for B is actually also constructive because throw meet with the throw, so this one is destructive. Alright, and for C is actually the crest meet with the throat. So this one is crest meet with the throat. This one should be destructive. Okay, and D is actually the crest meet with the crest. Alright, so this one is actually the constructive. Okay, constructive, destructive, destructive, constructive. This one is wrong. Why so many said D is? D is a constructive, right? Crest meet with the crest. Why so many said D is the C is a destructive, right? That one is a throw meet with the crest. This is a dotted line meet with the line here. So it should be destructive. ADD B is a destructive. Then where's your answer? Teacher, D is like it's on the two crest. Wait, let me check first. B is a constructive. C is a destructive, right? D is a constructive. Yes, yes, correct. No wonder someone. Yeah. D is not. D is. Yeah, this is actually constructive. Okay, so this one is a crest. Sorry, this one is a throw with the throw, so it should be constructive. So you got wrong. Sorry. Most of you got it correct. ABD is actually the constructive and C is the destructive. Only one is destructive. Okay, so wait for a moment. This one is wrong. Wait, I will use this one first. ABD. ABD. This one is wrong. Let's see the answer. Okay. Wow. All right. Got another. This one is just the one that I marked before. Okay. So next one, we move on to the calculation. So in the interference, there are one formula that you can use. Okay. To measure, let's say if you want to measure the wavelength. Okay. If you want to measure the at A is actually the distance. I will explain to you what is A, what is X, and what is T. Okay, so the first one, the lambda. So the lambda is actually the wavelength, okay, for the water source. So here you can see from crest to crest is actually the is equals to one wavelength. So here from crest to crest is equals to one wavelength, right? So or you can take from throw to throw here like this, okay? So that one also we call it as the one wavelength. Okay, so this one also we call it as a one wavelength, or you can take any other part, okay, as long as from the crest to crest or throw to throw. So it's considered to as one wavelength. Okay, and then for A, right? A is a distance between two coherent source, right? So from source 1 and source 2. Because you already know for the interference to occur, they need two source of water wave. Okay, so here where the distance between those two sources, okay, we call it as the A, right? So this is the A. Okay, from D, for D, D is actually the distance between the two coherent sources and also where X is measured. So from S here, from the source to where you measure your X. So let's say you measure your X here. Okay, so if you measure your X here means from here to the source is called as D. Okay, that is called as D. And X is actually the distance between two successive antinode line or nodal line. So what is the antinode line? Antinode line where you underline all the point, okay, that constructive interference occur. So you underline all that point, they will become one line, right? One straight line. So that line we call it as the antinode line. Okay. Antinode line is for all the point that where the constructive interference occurs. So you underline all that point. So when it become one line like that, you call that line as an antinodal line. So I give you example. So for here, the antinodal line is actually for the blue one. Alright. So here you can see the throw meet at the throw. So this one is a constructive. Okay. So this one is the constructive. Okay, constructive. And this one also constructive, right? Crest meet with the crest. And this one also is a constructive, throw meet with the throw. And this one is the crest meet the crest, again constructive. And this one is the throw meet with the throw. So this is also a constructive. So I will underline, okay, all the point here. Okay, all the point here. Okay, so this one will become the antinode line. Okay, so I connected all the constructive interference, and when we come one line, so this line we call it as the antinode line. Okay, how about the nodal line? So what is a nodal line? Nodal line is where I connected all the destructive interference. Okay, the point where the point where the destructive interference occur, I connected all that point. Okay, then after it become one straight line, then that line I will call it as a nodal line. Okay, nodal line is for the destructive interference. Okay, so let's say I give you example the red one. Alright, so let's take a point which this is, let's say this one. Okay, at this part, okay, this part is a destructive, right, where the crest meet with the throw. And this part is also destructive, crest meet with the throw. And this one is also a destructive and the crest meet with the throw. Okay, so that line, I will just connected it. Okay, I will just underline. Okay, I will just underline all the three lines there. Okay, then this line we call it as a nodal line. Okay, as a nodal line. Okay, so what is X? X is the distance between two successive antinode line. So means from here, whether if you want to take antinode to antinode or nodal with nodal. So let's say if I want to take antinode to antinode. So antinode is actually where all the constructive interference, right? So this one is the constructive interference. So my antinode is here. Okay, I use another pen. Okay, so my antinode is here. From here to here. Okay, this is called as X. Okay, so if I want to take nodal line, so if I want to take a nodal line, okay, I will take from here to here. So this is also, we call it as X. Okay, so it must be from antinode to antinode or node to node. Okay, and you already know that antinode is actually where all the constructive interference occur. Okay, we call it as antinode. Okay, antinode is where the constructive interference occur. While node is where the destructive interference occur. So just now, let's say like you give answer to me just now. For a moment. So this is A, and for let's say they didn't use a constructive, okay? So they use an anti-node or node. Alright, so for the anti-node is actually for A, B, and D. A, B, and D, we call it as anti-node because that is where the constructive interference occur. While point C, we call it as a node because that one is a destructive interference. So you can use these two terms to describe whether it's constructive or destructive. Okay, so constructive is anti-node, while node is the destructive. Okay, so that's the formula. Okay, if you want to find lambda, E, X, or D, okay, so that's depend on the question. Okay, so what happened during the interference? So let's say we have a two wave. Okay, the first wave, okay, it come from the left. Okay, so it come from the left, and this one is come from the left. Sorry, from the right. So during the interference, okay, so during the interference, these two wave will overlap each other. Okay, so there we produce the 2A. So A plus A is 2A. So that one we use a superposition principle. Okay, so after the interference, okay, both will continue to move with using their own they're using their original direction. So mean they say for this one they move to the left, so it will continue move to the left after the interference. And this one, they say it moved to the right. Okay, it will continue move to the right after the interference occur. Okay, that one is A plus A. So what happened is A plus 2A. Okay, so during the interference, okay, by using the superposition principle, right? So A plus 2A is actually 3A. Okay, so after the interference occur, all right, so they will move, okay, they will move back using their own original direction. So they will continue move to the left, and another one will continue move to the right. Okay, and this part is where the destructive interference occur. But after the destructive interference, okay, so you can see here the throw will keep moving to the left, while the crest will keep moving to the right. Okay, so it will continue they will continue back, okay, using their own original direction. Okay, and then the next part, okay, what is the factor that affecting the interference pattern? So the interference pattern, okay, is actually wait for what? The interference pattern depend on the value of x. Okay, so you already know the formula is lambda is equal ax over d. Okay, so when the x change, okay, the interference pattern also will change. So this is the equation. So they ask you to write the equation, okay. Lambda is equal ax of d over d in terms of x. Okay, so lambda is equal ax over d. So lambda d is equals to ax. Right? So lambda d over a, you will get x. Okay, so that is how you get this equation. Okay, they ask you to write the equation lambda equals to ax over d in terms of x. Okay, so that's the formula. All right, so I want you to calculate. Okay, I want you to find the value of x by using the formula lambda is equals to ax over d. So I already give you all the information here. Okay, the distance between two sources, all right, and this one is the what, and this is what. Okay, so I want you to find the value of x here by using the formula. Elvis, please join the class point. Wait, I give you the link. Okay. Okay, Daniel, Alex, Vision, Kaiser, Lavanya. Daniel, okay, 1.5, right? Can I see if you cannot give the answer in the chat? Okay, cannot give answer in the of on the class point. Okay. Alex, Vision, and Lavanya. Where is Lavanya? If you have internet problem, you cannot give your answer in class point. You can just write in the chat. I give you 30 seconds. Okay, before I forgot, for your final year exam, okay, I will take like 10%, okay, from your project. So if you didn't submit your project, or you did, means you didn't lose your 10 marks there. Okay, so make sure you submit your project, and if you can present, then please present. Where is Lavanya? Okay, so let's check your answer here. Okay, lambda is equals to ax over d. So what is actually the formula that you should use? So this one. So lambda is already given here. So I just mentioned to you whether you want to take crest to crest or throw to throw. So this one is throw to throw. So the lambda is 2, right? While A is the distance between two sources, there is a 4. A is 4. Okay, X you need to find. Okay, and D is actually where the distance between the source and where you measure the X. Okay, so let's say you measure your X here. Okay, until the blue one, the blue dots there. Okay, so D is 3 cm. So 6, okay, for X. So X will become 1.5 cm. Right, very good. Okay, some even very wrong. How you, alright. Please don't leave your answer in the fraction. Okay, if you leave your answer in the fraction, let's say you give like 6 divided by 5 example. Okay, even let's say if I calculate it, okay, it's 6 over 5. Oh, sorry, not 6 over 5. 1.5 is actually, this one is 6 divided by 4. Okay, so let's say you give your answer 6 divided by 4. Okay, actually it's correct, right? 6 divided by 4 is actually you get 1.5. But in physics, you cannot leave your answer in fraction. Please answer in the decimal point. Okay, so this one also is correct. Okay, very good. Okay, so the next part, distance between two coherent sources, alright? So for A, it asks you to compare the distance. So in the diagram, you can see, right? A for the diagram 1.5.8b, okay? Is further than diagram 1.588. Okay, so A is further than B. Right, so how about the distance? Okay, so here you can see the distance X, okay, for 1.5.8B is higher, okay? So B is higher than A. And what is the relationship of A and X? So it is the inversely proportional, okay? So it inversely proportional. We can also use the formula, right, to describe this one. So they ask you the relationship between A and X. So lambda D is equals to AX. Lambda D over A is equals to X. So let's say if you increase your A, okay, you increase your distance between these two sources, what happened to the X? So the X will become lower or it becomes shorter. Okay, so this one is actually shows, okay, it has the inversely proportional. Or you can say if they ask you the relationship for the for this kind of question, you can say that the higher the A, the lower the X. Also can. Okay, but that one you cannot use when they ask you to describe the graph, okay, the relationship of the graph. Okay, for another, the next question is said, state two other physical quantity that needs to be fixed, right, to ensure the top relationship is correct. So if this question, you have to refer back to the formula. Okay, this one, they use A and X. Okay, so you cannot use A and X. So you will left with the lambda, the wavelength, and also the distance between the source, okay, to where you measure your X. So this one, the two other physical quantity is the lambda and also the D. Okay, and the next one, they ask you to draw the graph X against A. So remember, X against A means the y-axis against the x-axis. So the y-axis should be X, the x-axis should be A. So when you draw the graph, Y is here and X is here. And we already know that, okay, so this is X and this is A, right? Okay, and from this one, they already mentioned to you, the relationship is inversely proportional. A is inversely proportional to X. So the graph for inversely proportional will be like this. Okay, so that's the graph. Okay, and then the next one, okay, we try to investigate, okay, what is the effect of the wavelength to the interference of wave. Okay, so the first one, you have to compare the wavelength. So the wavelength here, you say we take here from here, so crest to crest. And this one is Okay, so you can see for the diagram A, okay, the wavelength is higher than B. Okay, and about the frequency, okay, for the frequency here is B is higher than A, because you can see the wavelength there, okay, the wavelength there is much closer to each other. Okay, so this one also you can use the formula, right? V is equals to F lambda, lambda is equals to V over F. Okay, so when you increase the frequency, okay, the lambda will become decreasing. Okay, the lambda will be decreasing. So that's why you can see here the lambda is shorter than this one. This one is using this formula, okay, because they didn't give you any value of frequency here. So how can you compare? You use the formula, right? So you can see the difference here is the lambda, the wavelength, okay. So what happened here? You use the formula V is equals to F lambda. Lambda is equals to V over F. Okay, so if I increase the lambda, okay, the wavelength will become decreased. So you just compare which one is the wavelength is shorter. So this one. So mean at this part the frequency is higher. Right? So you compare the wavelength here. So the wavelength here is shorter. So you already know if the wavelength here is shorter, mean this one the frequency must be higher than A. So that's why it says here B is higher than A, the frequency. We use the formula here. Okay, and you need to compare the distance. So this one you can just see the diagram. The distance between X is shorter than the distance between distance of X, okay, for diagram B is shorter than A. Okay, so B is shorter than A. Right, so what is the relationship between lambda and F? Okay, so see, you can see again the formula here. So when the lambda decrease, the F increase. So this is the inversely proportional. Okay, inversely proportional. And then the next one, it asks you to, what is the relationship between lambda and X? So this one, you refer to this formula. Alright, so what happened? What is the relationship? So let's say if I increase the lambda, so what happened to X? X also increase. So this one is a directly proportional. So the next part asks you to state, alright, the two other physical quantity that needs to be fixed. Okay, this one they use a lambda and also the X. Okay, they use a lambda and X. So you cannot mention lambda and X anymore. So it will be left by A and also D. So A is the distance between two sources, while D is the distance between the source and where you measure your X. Okay, and the last one is draw graph X again lambda. So again, X will be at the Y axis and lambda should be at the X axis. So when you draw, this one should be X, this one should be lambda. Okay, so let's see the question again. It says X again lambda. So X against lambda is actually directly proportional. So you just draw the straight line that pass through the origin. Okay, so that's the answer. Okay, so the next part you have to investigate. So just now we already investigate wavelength. Okay, how does the wavelength affect the interference? Okay, and the next one is how does the distance between two sources to the point of measurement X, that is D, okay, will affect the X. Okay, so the next one is you have to state the relationship, okay, relationship between D and X. Okay, so based from this formula, okay, you have to arrange back, okay, the formula so you can find the relationship between D and X. Okay, so this is the formula. So for this one, the relationship between D and X, so when they say I've increased the D, the X also will be increased. So it will be directly proportional. Okay, and then the next one, take two other physical quantity. So this one, they already use D and X, so you cannot use it anymore. So you can use the A and also the lambda. Okay, so A is actually the distance between the two source, while lambda is actually the wavelength. Okay, and the next part you have to draw X against D. So again, Y against X. So X should be the Y axis, YD should be at the X axis. So when you draw the graph, it should be pass through the origin, and this is the graph. Directly proportional. Okay, so this is actually the conclusion. Okay, what happened? Let's say if the relationship for lambda is directly proportional to X. So if you increase the lambda, your X also will be increased. Mean the distance between two successive constructive or destructive interference will be further. Okay. So the fixed variable is D and A. So D is actually the directly proportional to X. So if you increase your D, your X also will be increased. So the X will become further. Okay, it will become longer. Okay, so the fixed variable here is A and lambda. While A is inversely proportional to X. So if you decrease the A, okay, X will be increased. Mean if your source is much closer to each other, okay, so the X will become higher, right? And the fixed variable is D and lambda. Okay, so the next one, we finished already about the interference of water wave. So we move on to the interference of light. Okay, so before I continue with the interference of light, so we learned already diffraction of light, right? So that is when the light pass through the single slit. Okay, then you can see there is a bright fringes and the dark fringes. Okay, while at the center here, at the center of the screen, okay, you can see there is a bright fringes. Whether the fringes is small or big, okay, that one is depends on the size of the slit, right? So the higher, the bigger the size of the slit, okay, then the fringes, okay, the size of the fringes will become smaller. All right, so that one we already learned for the diffraction of light. Okay, it pass through the single slit. How about the interference of light? So interference of light is actually when it pass through the double slit. Okay, there are two slits. Okay, and you use the laser. Okay, the laser light. Okay, and you point it at the slit. Okay, then they produce the interference of light. Okay, so this one is actually to show the interference pattern of light wave. So what is the apparatus you need? It's a laser pointer. Alright, a double slit, wide screen, meter ruler, and also the retort stand. So at first you have to measure the distance between the screen, okay, between the screen and also the slit, okay, the double slit that you use. Okay, so let's say it's 2.0. Okay, so when you start the experiment, when you point the laser, okay, through the double slit, you can see there is a red and dark fringes, okay, at the screen. Okay, the bright and also the dark one. Okay, so this one you have to measure, okay, the distance between the 5 consecutive bright red fringes. Okay, then you have to record it. Okay, this one is actually if you do the experiment. Okay, then after that you have to divide, okay, to find 1. Okay, so let's say this start from 1.8, right? And it's end at 9 cm. So you just minus 9.1.8 is actually 7.2. Okay, so this one how many? 1, 2, 3, 4. Right? So this one you divide by 4, you will get 1.8. So means from this one, from the bright dark red fringes, okay, to the next one is actually 1.8. And this one to this one also 1.8. This one to this one also 1.8. This one to this one also 1.8. Okay, so this one we will learn later how to calculate. Okay. So the red light from the laser pen is a monochromatic light. So for the water, they use a coherent source. So what does it mean by coherent source? They have the same wavelength, same frequency, and the same constant, okay, of phase. Okay, that one is for the water. They use a coherent source. Okay, means the source that we use to produce the interference, because you know they need two wave, right? So the interference can occur. So that two source must have the same wavelength, must have the same frequency, and the same constant phase. Okay, so that will then it will produce the interference of water wave. Okay, for the light, okay, the laser they use, the light that we use must be monochromatic. So what does it mean by monochromatic? Means it's only one color or one wavelength. Okay, so you cannot use like two color, okay, and then you try to make the interference. No, only one color and one wavelength. Okay, same color and same wavelength. Okay, these are the interference pattern observed when light pass through the double slit. So here you can see in the diagram, they produce the dark and bright fringes. Okay, so the bright fringes is depend, okay, what color is it, the color, the laser that you use. For this one is the red, right? So red bright fringes, okay, and then the dark fringes. Okay, they will be like alternately. Okay, so this is the formula. Wait, I show you the video for this one, for the interference of light. Any question you want to ask? Hmm. If you have any question, you can ask. Okay. Double slit interference. So let's see this video. Okay, so they use a red laser, yellow laser, and also green laser. Okay, this one is the identical double slit. Okay, so means they use three different colors here. Okay, but the slit, the distance of the slit is same. Okay. All right. Okay, so this is the interference of light. Okay, if you use a laser, then you pass through the double slit. Okay, so they produce like this. Okay. So this one is actually, you can see they use a different colors. Okay. And for your knowledge, right? So you already know the color of the, wait for a moment. Okay. So the color Roy beef. Okay. So this is actually the color of the rainbow, right? Red, orange, yellow, green, violet. Okay. So from here to here, from red to violet, the wavelength is decreased. Okay. So that you have to remember. Okay. From the red, okay, to violet, the wavelength of the color will decrease. Okay, so we refer back to the formula here. Lambda is equals to AX over D. Okay, so if the wavelength is decreased, what will happen to the X, right? So the X also will be decreased. So means the distance between the dark fringes to the dark fringes and also the bright fringes to the bright fringes, it will become shorter. So this one they use a red one, red laser, okay, and this one is a yellow and this one is the green. Okay, so you can see here red, yellow, green. So means the wavelength is decreasing, right? Okay, so when the wavelength is decreasing, you can see at the middle here, right? You can see the distance here is become shorter. Okay, the color become shorter. Okay, the fringes become shorter. Alright. So this is actually okay the effect. Okay, what will happen if you increase the wavelength? Okay, if you decrease the wavelength of the light. Okay, so when the wavelength is shorter, the X becomes shorter. So you can see here, right, at the middle especially, okay, at the middle especially, you can see it become shorter. Okay, so that's is what happened if you use different color. Okay, so this is the color that you use: red, orange, yellow, green, blue, indigo, violet. So how do you want to remember? For me, I just said Roy G. Beef. Okay, so when you move to the left, move to the right, the wavelength is decreasing. Okay, so this is the example of diffraction of interference of light by using the Young double slit experiment. Okay, so we move on to the next one. Okay, how about the calculation? Okay, so the wavelength of wave can be calculated using the Young formula. So we just use the same formula, okay, like the water wave, the interference of water wave. Okay, but the definition for lambda, for A, for D, and for X is different. Okay, for the wavelength means the wavelength of the color. So what is the wavelength of this? If you use the red color, okay, to do the interference, you use the red laser. So what is the wavelength of the red laser? So that is the wavelength. Okay, and A is actually the distance between double slit. Alright, so you use a double slit, right? And then you make the laser pass through it. So let's say this is the slit. Okay, and this is actually A. Okay, so that is A. And D is the distance between the double slit and the screen. So just now you can see there is a screen. They put the laser, okay, they show the laser on the screen. So from the screen to the double slit, okay, this is D. Okay, that one is D. So how about the X? Okay, the X is distance between two successive bright fringes. So if I use the video just now, okay, let's see if I use the video just now. So my X is actually from here to here or here to here. Okay, the dark to the dark or bright to the bright. Okay, so that is my X if I use this video. Okay, so for now, I want you to calculate the X and also the lambda. Okay, try to answer this one. Where is the X and also the lambda? If you have any question, just ask in the chat. Okay, don't need to wait for me. So this one also use lambda is equals to AX over D. Okay, you have to find the x first. Okay, you have to find the x first. Then you can use the formula lambda is equals to ax over d. So this one you have to find the wavelength. So the x is must be from the bright to bright or dark to dark. Okay, they already give you the measurement from here to here. This one I think already teach just now. How to find the value of x. Okay? Okay? Okay, Alex, Junket, 91, Hongqing, Julian, Ethan. You cannot give your answer in the class point, just give answer in the chat. It's okay. Alex, Junket, Wyman, Hongqing, Julian. Maybe I will stop until here, okay? That's too noisy. Until I listen, okay? Okay, so let's check the answer. So A is 0.5, it's already been given by the question, and also D is 2.0. So the question is need to find the X and also the lambda. So how you want to find the X? So remember X is from the bright fringes to the bright fringes. Okay, so mean it's from here to here, or you want to take from dark to dark. Okay, so you can choose. Okay, so from here is 1.8. This one is same like this one I just taught before. So this one is 9. Okay, so mean the distance of y is 9 minus 1.8. So you will get 7.2, right? So 7.2 is actually equals to how many x? So you have to find how many x is here. So 1, 2, 3, 4. So there are 4x here. So if you want 1x only, okay, so you have to divide by 4, you will get 1.8. So actually this one is 1.8. So you have to find lambda. So lambda ax over d. So a is 0.5, x is 1.8, and d is 2. So 0.5 times 1.8. Okay, and you divide by 2, you will get 0.45. Okay, so 0.45. Okay, so that's the answer. But wait for a moment. Okay. No. Because you can see the unit there. The unit is in millimeter. Okay, you have to change it first. Right? So let's say lambda is equals to ax over d, right? So lambda is ax over d. So a is 0.5 millimeter. So you need to change the milli first. The milli is 10 power of negative 3, the value. Okay. And the x is also in milli. So means 1.8 times 10 power of negative 3. Okay, 1.8 millimeter. So milli, you change it to 10 power of negative 3. And d is 2. Okay, you have to change all these to meter, right? Because the unit is not same. Okay, this one is meter, this one is milli. So you cannot just directly use it in the formula. Change the millimeter to meter first. Okay, so that will be equal. So then after that, you can just multiply. Okay, 0.5 exponent negative 3 times 1.8 exponent negative 3. Okay, and then you divide by 2. So you will get 4.5 times 10 power of negative 7, okay, meter. So this is the value of the wavelength. Right, so let's check if anyone got it correct. No. Can you understand for this one? Some of you got 0.45, but they didn't change it the unit. 10 power negative 5. Yeah, some I noticed they got 4.8. Still unsure. Alright. Okay, so never mind. I will teach you that one again. We give you another example. So can you understand for this one, how do I get 4.5 10 power of negative 7? Are you clear? Okay, I understand that one. Others, do you understand? Do you have any problem? Kaylee, Waylock, Daniel, Jian Hong, Jiang Wei, Jing Yi. Can you understand? Okay, so never mind. I will give you another example, okay, for the next class. Okay, so remember on Thursday is the last presentation. Okay, for those who still didn't present, please present on Thursday. Okay, so that is the last day. Okay, for those who are having a problem, okay, you can present on the when the school open. And one more thing, please remember, I will take like 10% for the project, okay, in your final year exam. Right? So make sure you do your project, at least you do your project, you submit in the Google Drive, okay, so I can give you mark, right? So I see you on Thursday, okay? So take care everyone, okay? Bye. Welcome. Thank you.